How's it going, everybody? In this video, we're going to take a look at both locally originated routes from the perspective of using the network statement, the redistribution statement, and then we're going to take a look at S Path Prepending. And the reason I chose to throw in locally originated routes is because of the fact that when you locally originate a route, meaning on router 1, if we type in router BGP and we type in an IP address via redistribution or the network command, regardless of how we do it, it's going to be advertised with a weight of 32.768. So that's going to give us a little bit of, it's going to mess us up a little bit if we're not sure why that's in there. So remember, you're seeing it come in and it's going to be local to that router. If you specify local to that router, it's going to be locally originated with 32768 as the weight. And if you're on the box and you see weight of 32768, that means that that router originated that route. If you're on another router and you don't see the weight, that means that it didn't originate that route, but you can see it as an I or a question mark depending on how it was advertised. And that's the key thing that I want you guys to take away from here, is you have to understand when you're in BGP, because it is the Internet Routing Protocol, it is the biggest protocol in the world, it is the protocol with the most capabilities, that is the protocol that messes the most people up. I walk into plenty of environments in the past 2.5, 3 years, and it blows me away how many times people go, well, I advertised the route, and I'm like, yeah, but you're not using the right attribute. And it's like, it's just a lack of understanding for the most part. You know, and you go in there and you point them in the right direction, and they're like, oh, okay. You know, and they're usually relatively, what's the word I'm looking, receptive to that. But the point that I'm trying to get across, which I think I've already hammered at home already, is when you're dealing with local origination, 32768 is the key thing you want to pay attention to. And that goes with the network command, that goes with redistribution, that goes with aggregation, which we're going to be covering soon here as well. And there's a question, am I going to be covering dampening and things like that? I know I'm not going to go into dampening. That's a little, it's more of an advanced topic, in my opinion. That's something when I'm actually planning on doing an entire BGP course where I go large scale, big network, and show you guys how that stuff works. I'm actually looking at doing like 15 CSR 1000 Vs and doing everything through that. But from our perspective right now, we're just going to do a little bit of S Path Prepending, local origination. So I'm on router 1 right now, right? So what we want to do on router 1 is we want to go to global config and do show IP interface brief. And right now we have a bunch of routes in here, right? So what I'm going to do is I'm going to type interface loopback 500. I'm going to type an IP address of 10.1.5.5, and I'm going to punch it in as a /16. Okay. Now by doing that, if I type in the do show IP interface brief again, there's the loopback in there now, right? It's up, it's running. If we type a do show run pipe section OSPF, I don't believe I'm doing, because I'm running 172.16. And okay, so it is there. So it's automatically getting redistributed in, which is fine. That'll work. So the idea now, if we were to go to router 9, for instance, and type in do show IP route, you would see 10.1. This guy right here coming in. And now, why is it coming with a /16? Well, it's because of the fact that it was advertised with the /16 mask. If we were to go to do show IP BGP, you would see this guy coming in here, but you don't know anything specifically where it's coming from. And it's redistributed in. Now, if we went to router 1, we were to type in router BGP 12345 and type in network of 10.1.5.0 /16. Actually, I wouldn't be able to type that in. I had to type in 0.0 /16. Oh, sorry, mask. Forgot the mask command. Mask, if you don't specify the mask, or use the mask keyword at the advertisement, it's going to default to its classful boundary. So a 10 is going to be a /8, a 172.16 is going to be a /16, and 192.168 is going to be /24. Now if we go over to router 9 again, router 9. Why is it doing that? Router 9. Geez Louise. There we go. Now we're going to see it coming in as 16 again, but if we do a show IP BGP, now it's coming in as a network command advertisement. That's the key difference between the two. Because the network command being an I route, being an IGP, meaning it was advertised via the network command, will take precedence over the question mark, which is the redistribution capability. So that's how that would work. So now if I was to do a do trace to 10.1.25.3, I'm going to get to 7, and 7's not going to know what to do with it because it doesn't know that route. But because of the fact that I have a /16 here, that's as far as it'll go. And if I do Control-Shift-6 there, what do I have to do? A 5.5. Okay, I see what the problem is. That's weird. Why is it doing that? What am I missing here? Do trace to 10.1.5.5. Oh, I see why. Okay. So if I did 25.3 again, it would get to router 1, but router 1 doesn't know what to do with it because he doesn't have an IP address configured. So it's going to take you to where it was supposed to go and to router 1, but router 1 doesn't have anything that matches that IP address, so the 10.1.25.3, but he has 10.1.5.5. So now, the one thing that you can use to influence how traffic comes back into your network is a technique called is called AS Path Prepending. Now, AS Path Prepending allows you to make the current AS path length look worse than it really is. So let's say, for instance, right now, if we were to do a show IP BGP, and if we were to look at where we're setting this stuff up, we see that for the 10.1, this route right here, right, is coming in off of router 137. Right. And the reason why it's coming in that way is because we have two AS hops. We have 13 and then 1, 2, 3, 4, 5. That happens to be the path that we're taking. Now, what if we wanted it to prefer coming in via router 6 instead of coming in router 13? Well, is there a way we could do that? The answer to that question is absolutely. Now I'm going to go to router 5, and I'm going to type in IP prefix list, and I'm going to do that. And what route were we looking at? We were looking at 7. We were looking at the 10.1/16. So we're going to go back to 5. We're going to type in IP prefix list, and we're going to say R1_loopback, R1_loop. We're going to say permit 10.1.0.0/16, and we're going to hit enter. Then we're going to permit 0.0.0.0/0 LE32, which means everything else. We're going to type in route dash map, and we're going to say AS path. Hit enter. We're going to say match IP address in prefix list R1 loop, and we're going to say set the AS path right there, AS path prepend, and we're going to say what is the number you want to prepend. Now, it is good internet etiquette to only use your autonomous system number. So we're going to use 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Now that's going to put 3 1, 2, 3, 4, 5s in front of the originating number, which means that when we see it, we should see 4 1, 2, 3, 4, 5s, and that should only show up on 13. So that when we get to 7, we should choose the path towards router 6. Now we're going to type in router BGP 1, 2, 3, 4, 5, address family IPv4. Type in neighbor of 135.0.0.1 route map, and we're going to say the name of the route map is AS path. Now, because we're trying to affect the way the traffic comes back into our network, we're going to affect this out to the out towards router 13 because we're trying to affect inbound traffic. Outbound, what's the word I'm looking for? Applying it out will affect incoming traffic, and then applying it in will affect outgoing traffic. So we're going to say out. And now we're going to type in do clear IP BGP star soft. Let's go to router 13 now and type in do show IP BGP. And you'll see that, well, that didn't quite work out. That's a lot more. Oh, you know why? Because I've got that statement in there. So basically what it's saying is everything now should go back in via router, what do you call it? Via router, it should all go 137, 13. It should all go via router 3. Let's see, where's 7 taking it? We should go via router 67. Now see how that works? Everything's going via router 7 that came from 135 or 12345. But notice one thing that it doesn't do. 12345 shows up once here, but if you look at 13, it shows up a bunch of times. So I'm actually go back to router 5, and I have to tweak that the prefix list. So I have to actually exit out of here and exit out of here, and I have to type in that prefix list. I have to tweak. Type in no. That should take care of that. So do clear IP BGP star soft. That should take care of that problem. Again, my mouse has been goofing up on me lately, so I do apologize about that. There we go. That's better. Because I only wanted to affect this route right here. Which if we go back to router 7 now, click on 7 and do show IP BGP. Now, router 7, we are choosing to go via router. Actually, let's do a clear IP BGP star soft. So now, if we were to do a trace route from, say, 9 and do a trace route to 10.1.5.5. Why is that? We'll work on 8. Trace route to 10.1.5.5. Alright, so we have that. Now if we trace route to do show IP BGP, show IP BGP, everything's going to go out 7, so if we get to 7 now, there are a lot of things that are going to be having us go router 67. Let's see here. Everything that's coming through there is going to be a 67. Let's do a trace route to 10.255.2.2. Okay. Well, everything's going that direction, and the nice thing about it is we go to 13, we're only affecting this route right here. So we're only affecting this route, and the reason why it's going via 135 or 137. No, I'm sorry. This is the best path. It's going on 137 is the best path to get there, but it's actually going out via router 6. So we do it, like I said, we do that trace. I'm sorry. That's on. This is router 13. That's why it's showing up that way. Because I was like, wait a minute, there's no 67 route. So the reason why it's showing up that way is because when we did the prefix list, we only matched on this particular subnet, the 10.1.0.0/16. That's the only route that we matched on. So that's the reason why it did what it did was because of the way we affected the route. And that's pretty much all there is to AS Path Prepending. Now there's a question: is there other ways to do it like you did earlier on? Doing the AS Path list and other attributes like that. There are, but typically speaking, if you were just to set the AS Path Prepending and you were to apply it on a neighbor and not match anything in the route map, it would match for everything. And that's how you would be able to get traffic to where you wanted to go via that. Now, typically speaking, if you have 2, 3, 4, 5, 6 connections out to the internet via BGP, and you only want to affect, you want traffic to come in a certain way, then that's one way to do that. And if that's how you want to forward it, you can. Just remember that that number, the AS path number, only goes out to the one hop beyond where you're at. So if you don't do it on the right neighbors to affect the right traffic, you might be finding yourself getting customer complaints where things are too slow because you're coming in on a slow link. So only add AS path numbers to on your neighbors where you don't want traffic to come in on. And that's the point of AS Path Prepending, is to try to affect how traffic will route back into your network, not how traffic will leave your network. So that's the one thing that everybody has to be cognizant of. As long as you understand that, you should be fine. So that's as far as I wanted to take this video. I wanted to give you guys a basic high-level overview of how that would work and go from there. So I hope this has been informative for you, and I'd like to thank you for viewing.